Uh, Good evening, all. So yesterday we are discussing about the metals and non-metals. So we will continue with this in the uh, last class. What we discussed. So here, yesterday we are discussing about the physical and chemical property of the metals and non-metals. So after completing that, we are discussing about what how do metals and non-metals react. So regarding this, yesterday I explained in brief. Today we'll go with in detail about this how do metals and non-metals react as. So you know that uh, see here, what metals are those? So they loses electrons. Metals are those they loses electrons. Metals are those they loses electron means loses electrons and becomes positive cations. Metals are those they loses electrons and they become what positive ions. So they are uh, so they are called electropositive in nature. So regarding this electropositive and electronegative, yesterday we discussed in brief. Today we'll go with in detail about this. Okay, now see here. Right. 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 They are given example. Sodium is a water electropositive in nature, and magnesium is also an electropositive in nature. So, which are the elements are electropositive in nature? It means the element which are going to lose electrons, they are electropositive in nature. If see here. So now when you go with what S block, P block, D block, in that S block elements. S block elements are electropositive in nature because as we move from move in the periodic table, see here when we move in the periodic table left to right, so slowly the electropositive character decreases, electronegative character increases. So that indicates what here. So the losing of electrons capacity decreases and gaining of electron capacity will be increased due to the what here. So you can say the reason for this one, right? So here reason for this is here. Uh, Sorry for disturbance. Right. See here, what happened here? Okay. We move from left to right, the electropositive character decreases, the electronegative character increase. Now in the when we see that ionic compounds occurs between the highly electropositive element with the highly electronegative. So here, so which are those highly electropositive means alkali metals and alkaline earth metals are highly electropositive in nature, and highly electronegative means the 17th group elements are highly electronegative in nature. They are given here. Sodium, it is atomic number 11 will be there here. So in the atomic number 11, so this first orbit which consisting with what 2 electrons, second shell which consisting with what 8 electrons, outermost orbit, or can say that outermost shell contains 1 electrons. So this outermost cell, or you can say that outermost orbit which contains 1 electrons, there is a very less attractive force between this outermost orbit and this nucleus of the sodium elements. Here this is the electron, and there is very less attractive force between this electron and the nucleus. Due to this reason, it can easily lose the electrons and the sodium will get the positive charge. Next here, so after the removal of one electron, the sodium is going to form what octet configuration. So that is what neon configuration it can take care. Neon atomic number 10 will be there. Now see here, so this is what we can see. Magnesium is atomic number 12. So in this magnesium, so when we see the 2, 8 and 2 will be there. It means what? In the first cell, K cell, we can have the 2 electrons, and L cell have the 8 electrons, and M will have that 2 electrons will be there. So now outermost cell, or we can say that outermost orbit, which contains only 2 electrons, they can loses the 2 electrons, and the by losing it can show that Mg plus 2. It is a Na plus 1 and Mg plus 2 will be there. It means 2 electrons is going to lose. I can say that its oxidation number will be 2 here. So now here the electrons which are lost by the element, so we can represent at the product side here. So okay, left hand side is reactant, this will be the product. If I write 1 plus electrons means sodium atom, it loses 1 electrons, and I wrote here uh, Mg plus 2. So Mg plus 2, 2, 2 means the magnesium, it loses 2 electrons. See if here any element with a charge will be plus, means that understood what the element is going to lose electrons. If any element with a negative charge means that element can gain the electrons. See here all the electropositive element they have the plus charge, the electronegative element have minus charge will be there. Now see here non-metals. So non-metals are electronegative in nature because they have the tendency to gain the electrons. Why the non-metals have tendency to gain electrons? Why the metals have tendency to lose the electrons? Because when we see the non-metals, they are given examples here, chlorine, right? We can see here they are given example what here, chlorine, right? I will take here fluoro, right? Next I will take here chloro, right? So fluorine, chlorine, fluoro, chloro, bromo, iodo, these are the 17 group elements are there. So atomic number of fluorine will be what here, 9, and atomic number of chlorine will be 17. So see here why these non-metals are electronegative in nature, because the outermost cell will have that highest number of electrons will be there. So now right here K, and next L, and this will be what, M will be there here. K shell contains 2 electrons. Next K and L shell contains 7 electrons. So M does not have any electrons for this fluorine. It means outermost shell contains 7 electrons. So due to the 7 electrons, the attractive force between the nucleus and outermost shell will be outermost shell electrons will be more. So due to that reason, instead of losing, they start gaining the electrons. And same thing here, chlorine, or you can say that chloro. So it atomic number 17, you can take a K shell, and here L, and next you can take a KL, M shell will be there. We know that K shell contains 2 electrons, L shell contains 8 electrons, and again M shell contains what here, 7 electrons. So 2 plus 8, 10, 10 plus 7, 17. It means the outermost shell of this chlorine contains 7 electrons, and outermost orbit or outermost shell of fluorine also contains 7 electrons. When you see this 17 group, all the element present in the 17 group, they have 7 valence electrons will be there, and due to this 7 electrons present in the outermost orbit, they start to gain the electrons, right? So these are the highly electropositive in nature. So here they are given Cl, right? Cl plus 1 electrons, it gives into what, Cl minus. So it indicates what, chlorine can gain 1 electron. After gaining the 1 electron, the charge will be going to form what here, minus. And here, so if I write general one more example, if I take here F, fluorine, so if it gain the electrons, F plus 1 electrons, it gives into what, F minus, right here, F minus. So chlorine, once it gain the electrons, it converting into what, chlorine minus, Cl minus, we can say this will be what, chloride. So we can say what here, chloride. So this is what here, chloride. So it is a chlorine atom converting into chloride ion. Now same thing here, fluorine atom converting into fluoride ion. So now when I use the word chloride and fluoride, so you can see that that will be at charged particles will be there. So here in this 2 electrons, 8 electrons, and 7 electrons in the outermost shell, and it going to gain 1 electrons. After gaining that converting into what, octet configuration, that is what, argon will be occurs here. Now see here they are given one more example will be there here. Oxygen they are given here, right? So you can see right. So they are given oxygen. So its atomic number will be what here? 8. Oxygen atomic number will be 8 here. So now atomic number 8 oxygen. So here atomic number of oxygen will be 8 right here. So K shell contains 2 electrons, K, L, and you can take a M. K shell contains 2 electrons, and next L contains what? How many electrons here? 6 electrons. Total 8 electrons are there. Outermost shell contains 6 electrons. It will be less electronegative than what? Fluorine. So fluorine contains total 7 electrons in the valence shell, and chlorine contains 6 electrons in the valence shell. When you compare the electronegativity of this non-metal, so with the element which contains more number of electrons in the valence shell or outermost shell, they have that more electronegative in nature. They contain less number, they are less electronegative in nature. Now see here once we can see this one. Now we it clear electropositive and electronegative element. I'll clear once again. Electropositive elements are those they are readily lose the electrons. Electronegative elements are those they will gain the electrons. See here. So this just you can observe these two reactions. In the electropositive element, the electron lost by the element they return in the product side. In the electronegative, electrons gained by the element they return in the reactant side. So here also there is a one clue for identifying the electronegative and electropositive element. Okay. So next we can move towards next one. See here. So formation of sodium chloride molecule. See here, by taking the electropositive element and electronegative element, we can form the sodium chloride as a ionic compound. Or else we can say that whenever the metals and non-metals combines, there is a formation of what sodium chloride. Or you can say that that's some compound which is occurs by that metals and non-metals. See here when you take a highly electronegative with highly electropositive, there is a formation of ionic compound will be there. NaCl, it is what? Ionic compound. NaCl what here? Ionic compound, because in this case, the complete transfer of electrons take place between electropositive element, right? The complete transfer of electron take place by the electropositive and gain of electronegative element. So now see here, it is a reaction given here. So this Na dot is indicating here. So how the sodium chloride will be occurs here? That here. So when you see this Na dot, it nothing but it is a Lewis dot symbol for sodium. So what is here? So why they are wrote only this dot is here? So this dot indicates in the sodium atomic number 11. Na atomic number what here? 11. Right here. Sodium atomic number 11. See here you can take a K, L, and I'll take here M. In the K shell 2 electrons, in the L shell 8 electrons are there, in the M shell only 1 electrons. So this whenever we are writing the Lewis dot symbol for any element, we can represent what valence shell electrons on the symbol of the element. So Na is the symbol of element. We wrote just this dot indicates what? So this indicate only 1 electrons in the valence shell. So it is that valence shell. M is the valence shell because it is the outermost orbit or outermost main shell will be it contains only 1 electrons. Next here they given that here Cl. Chlorine which contains how many electrons? 1, 2, 3, 4, 5, 6, 7 electrons. Just I wrote the electronic configuration of chlorine and we saw that the chlorine atomic number will be what here? 17. Atomic number 17 it contains K, L and here write M. It contains 2 and 8 and this will be what? 7. It means the valence shell of chlorine contains 7 electrons. Valence shell of sodium contains 1 electron. So in these two, so number of electrons present in the valence shell of chlorine will be 7 and sodium will be 1. It means sodium is loses electrons and by losing it can gain a Na plus charge. So chlorine will gain the electrons, by gaining it can gain what, have the minus charge. Here both sodium and chlorine will lose one electrons, chlorine will gain one electron. So due to this, we can write minus plus minus 1 and plus 1. Now see here 1 2 3 4 5 6 and this is 7. So these are 7 electrons present on the chlorine. Now here sodium after losing one electron it goes to water plus sign, and here chlorine after gaining one electron get minus charge here. So this bracket which indicate there is a attractive force between these sodium and chlorine. Whenever any ionic compound will be occurs in between highly electropositive with highly electronegative, we can symbolize what, so these dotted lines will be there, right? This dotted lines which indicate formation of ionic bond between the highly electropositive and highly electronegative. And here there is a formation of what, sodium chloride. Sodium chloride is a ionic compound. So when this here just we'll discuss about this types of what compounds. Ionic compound, right? Ionic compounds are there. Next covalent compounds are there. Next covalent coordinate covalent coordinate compounds are there. In this ionic compound there is a transfer of electrons, right? Here transfer of electrons take place between the two atoms, and here sharing of electrons take place between what, here sharing of electrons take place between the two atoms, and in the coordination covalent coordination compound sharing of its own electron to neighboring element. So regarding this we'll discuss in the PVC first year part. Just you know that what here just you can remember the types of bond, right? Covalent bond, ionic bond and coordinate bond will be there. So we are only focusing on what, ionic bond. Ionic bond means what, there is a complete transfer of electron takes place between the highly electropositive and highly electronegative. And see here for the formation of ionic bond there is a we need of some rule will be there, so that the electronegativity difference will be more than 1.7, so that they can form the covalent ionic bond will be occurs in that case, right? Now see here here. So regarding this formation of sodium chloride, they are given here. The An atomic number will be what, 11. Atomic number of chlorine will be 17, and EC means what, here electronic configuration. K contain, and here K L, and this will be M here, and same thing K L, and this will be M, right? So it can lose one electrons, it can gain one electron. There is a formation of NaCl. The atomic number of sodium is 11, and its electronic configuration is given to 8. And next one valence electrons will be there. It loses one electron to form Na plus. Iron, the atomic number of chlorine will be what, 17. Its electronic configuration will be what, here 287, and it has 7 valence electrons will be there, 7 valence electrons, and it gain 1 electrons. By gaining it will get what, Cl minus charge, Cl minus. Then the attraction between the sodium ion and you can say that the chloride ion, the resulting in the formation of what, here resulting in the formation of sodium chloride ionic compound, resulting in the formation of what, sodium chloride ionic compound. Okay, so next we can move towards the next one. There is a formation of magnesium chloride. See here magnesium chloride. So sodium is a alkali metal, magnesium is a alkaline earth metal. Both are electropositive in nature, but thing is there, sodium have, right, oxidation number +1. It means sodium can lose us 1 electrons. Magnesium can have oxidation number +2. It means it can lose us 2 electrons, right? Now you can see here how the magnesium chloride will be occurs. Now there is given magnesium will be there. Mg is a symbol of magnesium. So An atomic number, so its atomic number will be what, here 12, and they are given Mg +2. So this indicate what, the magnesium is readily lose the 2 electrons. That 2 electrons will be written at product side. It means the magnesium going to lose, and there is a formation of electropositive in nature. And they are given chlorine Cl, right? One electron, so means the one electrons will at a reactant side, that indicates chlorine gain the electrons, and there is a formation of chloride ion. Now Cl atomic number will be 17, and electronic configuration 2, 8 and 7. 2 plus 8 10, 10 plus 7 17. So it gained the one electrons, and it added to what outermost shell of this chlorine, and there is a formation of 2, 8. 8 is the electronic configuration of what chlorine. Now here the Lewis dot symbol for this magnesium and chlorine. So this two dots indicate what here? Two dots which indicate there is a presence of two electrons in the outermost shell of the magnesium, and here they are given 1 2 3 4 5 6 and this is 7. Should not take this Cl2 they are given, because if magnesium is ready to give two electrons, the capacity of accepting chlorine will be only 1 for one atom of chlorine. So for that we need out two atoms of chlorine. So here in this case, here we I shown that one chlorine atom is converting into chlorine. We can take a two chlorine atom for accepting a two electron. For that, it is representing what two chlorine atoms when converting into chloride atoms here. So chlorine is a diatomic molecule. We can write a Cl2. Chlorine is what diatomic molecules. It can represented with Cl2. When it converting into chloride ion, we can write 2Cl minus. 2Cl minus. Whenever they are asking that representation of Lewis dot symbol, we can write like this, or else just you can write the formation of magnesium chloride. No need to go for what these things. Just you can write what Mg, right? Mg plus Cl2. It gives into what MgCl2. MgCl2. It means what here? Magnesium is ready to lose electrons. Chlorine is ready to gain electrons. There is a formation of what? MgCl2 as a what? Ionic compound will be there. Right? So it is a equation. So when they may ask, write the Lewis dot symbol or a complete explanation of that formation of magnesium chloride, means you can write all these things, right? So these Cl they are representing one Cl atom contains 7 electrons. Second contains 7 electrons will be there. After combining, we'll get MgCl2 here, right? And here the atomic number is 12. Electronic configuration will be 2, 8, 2 for what magnesium, and it can loses 2 electrons, and it get what Mg plus 2. And next atomic number of chlorine will be 17. Its electronic configuration 2, 8, 7, and valence electrons will be 1 for each atom. And so Cl minus after converting chlorine atom to chloride. We can see here, if I write only Cl, it is a atom. If after gaining one electrons, it converting into chloride ion, we can pronounce as a chloride ion. So right here NaCl, NaCl. We cannot say sodium chlorine. We can say what? So sodium chloride. I can take a KBr. So KBr, potassium bromide. Right? So HCl, hydrogen chloride. Right? And next you can take what? NaBr, sodium bromide. It means halogens when they converting into ion. We can say that halides, respective halides will be there. Right? So now we can move towards the next part of this one. Next, what is there? Ionic compound and electrovalent compounds. So here, ionic compounds are compounds formed by the transfer of electrons. Transfer of electron from metal to non-metal. So here, metal to non-metal will be there. Now, you can see here, what are the properties of ionic compound? How the ionic compounds are there? See here, they are formed by the transfer of electrons. They are formed by what? Transfer of electrons, and are made up of ions. So here, if ionic compounds occur, means it completely transfer the electrons. And the covalent compound means it is a mutual sharing of electrons take place between what? Two atoms. For example, if I take a carbon with the 1, 2, 3, 4 are the valence electrons. Hydrogen, 1 valence electrons. There is a mutual sharing of electrons take place between carbon and hydrogen. We can take 4 hydrogens here, 1 and 4. Second, I'll take this is third, and this will be 4. And there is a 4 covalent bond takes place between the carbon and hydrogen. So what? It is a covalent bond between the two atoms. So here in this ionic bond means a complete transfer of electrons take place. So here the atom is going to lose electrons, other atom is going to gain the electrons. Next, these ionic compounds, they are crystalline solids are there. They are what? Crystalline solids. It means as like a sodium chloride is a table salt. Next here, they have high melting point and boiling point will be there. High melting and boiling point. So next, this high melting and boiling point due to the water high water. There is a large attractive force between the two atoms. They are soluble in water but insoluble in organic solvent. Here, so which are the organic solvent here? Petrol, kerosene, and you can take a alcohol. Right? So these are water, and you can take a CCl4, carbon tetrachloride is also organic compound. So water insoluble, soluble in water, but insoluble in organic solvent. So organic solvents are non-polar in nature. Water is a polar in nature. So it means so these crystalline ionic compounds are soluble in polar solvent and insoluble in non-polar solvent, and they conduct electricity. They conduct electricity in aqueous solution and molten solution. They will not conduct electricity in solid state. This here, so this ionic compound conduct electricity in aqueous solution and molten solution. Aqueous means salt plus water. Sorry, water solute plus solvent. Solvent must be water in the aqueous solution. Now here, these ionic compound is a very bad conductor when they are in the solid form. So when it is a good conductor means when they are in the solution form, these can conduct electricity. So this is a diagram they are showing that it is in the CL. So this is what inside this beaker we took a electrolyte. It means which can conduct electricity. When we pass electricity here, the two what and will be connecting with this bulb. When the electricity passes through this electrolytic solution, and the light will be glow inside this. So this indicate what these what ionic compound they conduct electricity. So next we can move towards what so this it is what reduce syllabus. So by this we can complete the metals and non-metals. So after this we can move towards the MCQ discussion will be there. Now we'll move with what MCQ discussion. See here, right? So after completing these metals, non-metals and metalloids, we can go with what some MCQs. It means multiple choice questions will be there. So in this, which one of the following metals do not react with cold as well as hot water? Which one here? Sodium, calcium, magnesium, and iron. In this, which one is not reacting with cold and hot water? So you know that yesterday I said that reactivity of the metal. So this question is based on what reactivity of metals will be there. In the reactivity, we can say that alkali and alkaline earth metals are very reactive in nature. And when you see that, so which are those? Potassium. Next, sodium, right? Sodium, potassium, sodium. Next, calcium and magnesium will be there. Calcium and magnesium, calcium, and this what here? Magnesium. So these are the very reactive metals are there. After that, we can go forward. Aluminium and zinc, right here. So aluminium and zinc will be there, and there again what? Sodium, calcium, potassium, magnesium they are given, and one more thing, after the zinc we can go for what, iron will be there. So this is what, reactivity series of this element. So potassium is more reactive than the sodium. Next, sodium is less reactive than the potassium. Next, calcium is less than the magnesium. Magnesium is less than the uh, sorry, aluminum is less than the magnesium. And next, zinc is less than the aluminum, and iron is less than the zinc. It means very less reactive will be what here, iron. So the answer will be what, Fe, right? Sodium, calcium, and magnesium they react with the water, and they give in respect to oxides. And iron is also react with water, but when it is in water, steam they react with the, and there is a formation of the respective oxide, but not in the cold and hot water, right? So next, we can go for next question. So here, which of the following oxides of iron would be, which of the following oxides of iron would be obtained on prolonged reaction of iron with steam air, right? See, which of the following oxide of iron, iron means you can take here Fe, right, would be obtained on prolonged reaction of iron with steam. So here FeO, Fe2O3, Fe3O4, and Fe2O3 and Fe3O4. In this, which is the correct option? See here, as we discussed here, so iron is very less reactive compared to remaining alkali and alkaline earth metals. So it is less reactive when it, see, oxides of iron would be obtained on prolonged reaction. It means, so we need to take water at uh, steam. When they react with the iron, they gives into water respective oxides. So for that, you'll get after prolonged heating, you'll get Fe3O4. Right here, Fe3O4. Fe3O4 will be there. So it contains what, FeO, and next Fe2O3 will be there. So here the mixture of what here, FeO, and you can say that Fe 3 Fe2O3. It means, so this indicate what, in the, in this what compound iron means, so that Fe plus 3 and Fe plus 2 oxidation state will be shown by this iron. So first it converting into ferric what, oxide, and then it converting into the respective Fe3O4 will be there. Ferrous oxide converting into ferric oxide. So after prolonged heating, it gives into what, Fe3O4 as our answer. So next, we can go for next one. So here in this question, see what they are given here. What happens when calcium is treated with the water? You know that calcium, when it treated with water, it does not react with water. Next, it react violently with water. It react less violently with water. Bubbles of hydrogen gas formed stick to the surface of the calcium. So they are given. So these are the four options will be there. So now can select in this which are the correct. More than one or two correct options will be there. What is the question? What happens when calcium is treated with water? Right? We know that alkali and alkaline earth metals, when they react with water, there is a formation of respect to hydroxides. It means they give the base, because that alkali will be the alkali means they give the some basic nature, right here. It does not react with water. It is not correct, because when they react with water, they give into water respect to hydroxide. Calcium hydroxide will be possible. It say next, it react violently with water, right? Sodium and potassium, they react, they are very more reactive in nature. They can react violently with water. They can catch us fire when they react with the water and air. Now see here, it react less violently with water, right? And next, bubbles of hydrogen gas formed stick to the surface of the calcium. So whenever the calcium is dissolved in water, there is a formation of water, calcium hydroxide, and removal of hydrogen gas. With this, there are some small bubbles will occurs in that solution. So that water here third and fourth are correct. It react less violently with water comparing to very reactive elements, sodium and potassium. And when it react with the water, bubbles of hydrogen gas will be released. Bubbles of hydrogen gas released and stick to the surface of the calcium. Because of that reason, when the calcium dissolved in water, there is a evolution of hydrogen gas. So now the correct option will be what? D, because so these 3 and 4 are the correct will be there. So 1 and 2, 1 it does not react. So calcium always react with water, and it does not react violently as like a sodium. So it is what? First, second and third are the wrong options. So correct will be what? Fourth one. Okay. So next we can move towards the next question. See here. Uh, Generally, non-metals are not lustrous. Lustrous means a shining property of that metals. Which of the following non-metals is lustrous? So we know that when we see the physical properties of metals and non-metals. So in that we learn that metals are lustrous in nature. So we know that all the metals are having the shining in nature, but non-metals are they does not have the lustrous property. But what is the question here? Generally, non-metals are not lustrous. Which of the following is following? Non-metals are lustrous in nature. See here in this sulfur, oxygen and nitrogen. So these are the water elements present in the P block: sulfur, oxygen, nitrogen. So nitrogen, sulfur, oxygen, these are the P block element. Is iodine is also P block, but iodine is having that shining in nature. Iodine have the shining in nature remaining. So 1, 2, 3 are the non-lustrous and iodine will be lustrous in nature. Okay. Next we can go for what? Uh, which of the following? Which of the following property is not? Which of the following is not a property of non-metals? Right? And we know that property of metals and non-metals. Which is not a property of non-metals? They are given. They are neither malleable nor ductiles. Right? Neither malleable nor ductiles. Is it correct? Because only metals are malleable and ductiles. Non-metals are not malleable and ductiles. They are brittle. It is also right. Right? They are brittles and they are sonorous. Here, which is not. It is here. Following is not a property of non-metals. So the non-metals they never show the sonorous property. As I said that in last class. So this what? Sonorous means after hitting, after that there is those non-metals can produce as a sound, as we know that bells which is present in the temple and school, right? So after the hitting that there is a formation also produce what there is a sound will be occurs in that case. So in this non-metals it is not possible. It means they are not sonorous in nature. What about the fourth one? They are poor conductors, poor conductor of heat and electricity, except they are given graphite, right? So because why they are given except graphite? So graphite is what? Allotropic form of carbon. It is a good conductor of heat and electricity, right? Sorry, it good conductor of electricity, right? So 1, 2 and fourth are what? Properties of metals, and third is not a property of non-metals, right? Right. Next we can go for next one. See here, a reactive metal is treated with the sulfuric acid. See here, reactive metals are treated with the sulfuric acid. Sulfuric means H2SO4. They are given here DIL. It means dilute sulfuric acid. The gas is evolved and is collected over the water as shown in the figure. See here, this is the water. When the sulfuric acid reacts with water, there is a evolution of water, a liberation of gas molecules collected over this water. Right? Figure. The correct conclusion drawn is or are there given. Right? What is the question here? Reactive metals is treated with the sulfuric acid, dilute sulfuric acid. The gas is evolved and is collected over the water as shown in the figure. So here, in this case, see what happened here. The gas is hydrogen, right? Conclusion: the gas is hydrogen. Next, the gas is lighter than air. The gas is sulfur dioxide and is lighter than air, and both A and B. See here, in this case, whenever the active metals like sodium, potassium, rubidium, so these active metals when they react with the sulfuric acid, for example, if I take here sodium Na plus H2SO4, Na plus H2SO4. When it gives RCl in presence of dilute acid, in that sodium react with the dilute acid, there is a formation of what? Sodium sulfide, Na2SO4. Sodium sulfide plus H2 gas will be liberating this reaction. You can take a 2. So now see here, the gas is hydrogen. The gas which is liberating during this reaction, that will be what? Hydrogen gas. H2 gas will be liberating. That is correct. Next here, the second one, the gas is lighter than air. Next, the third one, the gas is SO2. The gas here, first and second both are correct. Gas is lighter than air. It is correct. Now the gas is sulfur dioxide and is lighter than air. It is now sulfur dioxide is heavier than air will be there. So it is the third option will be what? Wrong. And both A and B, because given for this question A, B are correct. So for that the option will be what? Both A and B. Don't take A. So the gas which is liberated during this reaction will be hydrogen. Yes, that is correct. But the fourth option will be there, both A and B, because A and B are the correct for the given this question. So you can select what? Fourth D. Both A and B will be there. Right? Next we can go for next one. In this, which of the following metal will not give H2 gas with the water? H2 gas with the water. See here, as I wrote the reactivity series. Reactivity series, how it will be here? Potassium, next sodium, next we can take potassium, sodium. Next we can go for what? Magnesium, next calcium, right? After that you can go for aluminium, next you can take zinc, and next you can take iron. So this is what reactivity series of reactivity series of this given element. So potassium, sodium, magnesium, calcium, aluminum, zinc, and iron. They are given here. Sodium will be there. Sodium, magnesium, zinc, and copper. So here copper is below of this iron will be there. So it means water. So reactive metals, very reactive metals, when they react with water, there is a formation of the respect to oxides, and there is a water liberation of H2 gas. Sodium, magnesium, zinc are the reactive metals are there, and copper is a very less reactive nature. So it does not produce hydrogen gas when react with the water. So when so for this, so copper is the correct answer. Sodium react with the water, there is a formation of sodium hydroxide and liberation of H2 gas. Magnesium react with the water, there is a formation of magnesium hydroxide and H2 gas will be there. Same for zinc. And for this copper, it is a very less reactive nature. For this copper does not give H2 gas with water. Right? Next, see here, what is this question? In each test tube, in each test tube, zoom in here. In each test tube, A, B, and C will be there. I'll take here three test tube. This is what A, and this will be what B, and third one will be what here C. There are three test tubes are there. In each test tube, A, B, C, and they are given one more D will be there right here. Right, fourth one. A, B, C, and D. So these four test tube contains what? 2 ml of solution of aluminum sulfate. So here, right here. So this 2 ml of all the contains what? 2 ml, 2 ml, 2 ml of solution will be there. Which is that solution here? Which is that solution? Say 2 ml solution for this 4 test tube in aluminum sulfate right here. Al2 SO4 taken thrice. Al will be plus 3 charge and SO4 will be minus 2 charge. Interchanging will get the Al to SO4 taken thrice. Aluminum sulfate. So this is what A, B, C, and D contain 2 ml of aluminum sulfate in water was filled. Right? So these water. So these what filled by test tubes are filled by what? Aluminum sulfate. 2 ml of aluminum sulfate along with the water. So clean piece of zinc was placed in test tube A. Like give name for this one. So this is what A, and this is what B, and this will be C, and this will be what D. So for a clean piece of zinc was placed in test tube A. So here, so we dropped zinc in A test tube, and clean iron nail was put in test tube B. Iron means you can take a Fe. Right? And next in test tube B we are putting what? Fe. Next silver was placed in test tube. Silver was placed in the test tube C here. Right? So this is what C is. Silver means you can take a symbol of silver will be Ag. Next silver. C contains what here? Ag. And next and a clean copper wire was placed in test tube D here. So D means what? This will be copper. So this copper will be placed in the test tube D. So which and clean copper wire was placed in test tube D. Which of the following option is correct about the experiment? As you saw this in the last class, so displacement reaction will be there. So more reactive metals can displace us less reactive metals. Right here. So they are given. So just how to solve this one? Looking like very big question, but it's very depends upon the reactivity series. This question will be there. I'll repeat the question once again. In each test tube, so we took a 1 2 3 4, or consider A B C D as the 4 test tubes are there. All these 4 test tubes filled with what? Aluminum sulfate. How much quantity? 2 ml of aluminum sulfate along with the water. In water was filled. So in these 4 test tube, the A test tube with what? Zinc, right? And B will be iron, and C will be what here? Silver, and D will be copper. So after this, which of the following option is correct here? So now what is the 4 options? Depends upon that we can decide which is the correct one here. Zinc is more reactive. Zinc is more reactive than aluminium, and copper is more reactive than aluminium. Zinc is less reactive than copper. Zinc, iron, silver, and copper are less reactive than the aluminium. See here, they are asking that what which of the following option is correct about the experiment? Right? Zinc is more reactive than aluminium. Right? So when you see the reactivity series, I'll write one second here. The reactivity series, first you can write potassium, next sodium, next you can take magnesium, next you can take calcium, next aluminium, next zinc, after that iron will be there. Which are the element? Zinc, iron, silver, and copper. Right? So after this Fe, after the Fe we can take Pb, and next Fe we can take a Pb, lead, Pb, then you can take a hydrogen. Hydrogen, after that we can go for copper. After that we will take a copper, next mercury, next silver, next gold will be there. Right here. So we can select silver is very least reactive element comparing in this 4. Silver is what? Least reactive, less reactive, right? Less reactive in nature, less reactive, right? Next more reactive will be copper, more than this one. It means copper is more than the silver. After that iron is more than copper and silver. Iron is what here? More than copper and silver. Next zinc is more than that of this iron and silver will be right. Right. So you can see here in this case zinc is more reactive than aluminium. Zinc is more reactive than aluminium. So where is aluminium here? No, because zinc is less reactive than the aluminium. So here aluminium will be there. Aluminium is more reactive than the zinc. Zinc is more reactive. So it is the first option is wrong, because aluminum is more than that of the zinc will be there. Right? But they are given zinc is more than the aluminum. Next copper is more reactive than aluminum. See here, copper is here and aluminum is here. So copper is more. So copper is less reactive than aluminum, but they are given copper is more reactive than the aluminum. Zinc is less reactive than copper, right? Zinc is less reactive than the copper. It is also wrong here, because zinc is more reactive than copper. Next, zinc, iron, silver. Zinc, iron, and silver and copper are less reactive than aluminum. This will be the correct here. Right? This will be the correct. Zinc, iron, silver, and copper are less reactive than the aluminum. This because when you see the reactivity series First, potassium, sodium, magnesium, calcium, aluminum, zinc, iron, lead, hydrogen, copper, mercury, silver, and gold will be there. So, zinc, iron, silver, and copper are the less reactive than the aluminum. So, fourth option will be the correct here. Right? So, just they are given. So, it means aluminum can displace as less reactive elements. Right here. Next, we can go for next option question. See here. Zoom in, not zoom out. So this question here. In this question, on the basis, I'll zoom out. See here. Wait. On the basis of sequence, of the given reaction, identify the most and least reactive element respectively. Most and least reactive element. If they may give the name of the element, it is very easy to select the correct option. But they are given in place of element name, they are given X, Y, and Z will be there. So as you know that, just I wrote that reactivity series given in that. But see, on the basis of sequence of the given reaction, identify the most reactive and least reactive element respectively. Here what, by this reaction we can understand that X plus Ya, X plus Ya can give Xa plus Y. It means X can replaces the Y. It means X is a more reactive element than the Y. And here X again can replaces Y, and it gives on tot XB, right? Here XB. So next X is more reactive than B. So X is more reactive than A, and X is more reactive than the B will be there. And here Z can replaces X here. Z can replaces X and gives on to ZA plus X. So now here X and Z and Y and Z and Z and X, Z and Y. So this is what fourth option is the correct, because here X can replaces Y. Right? In these two cases, it replaces Y. But Z, it replaces X. It means X is more what? Reactive than Y. Right? But Z is more reactive than what here? X. Z is more reactive than what? X. So this indicate what? So Z and Y. Z is more reactive, or you can say that most reactive. Y will be what? Least reactive. See, here is very interesting question. So we can understand. So when you know the things about displacement reaction, displacement as well as a reactivity series. So we know that more reactive element can replace as a less reactive element. So based on this question will be there. Okay. So remaining thing will continue in the next class. Okay.